So we move on to the laws of logarithm, having considered the meaning of logarithms in the last video. So the laws of logarithm. So our expectation here will be that by the end of this lesson, we'll be able to expand logarithmic expressions correctly, condense logarithmic expressions correctly, apply product, quotient, and power laws reliably, and handle mixed expressions systematically. And we use the change of base formula confidently. All right. So first off, again, what is logarithm? We've talked about this in the last video. A logarithm simply answers the question, to what power must the base be raised to get this particular number? So log x base b equals y means that to what power should you raise b so you can get x? So, and that the answer is that if you raise b to power y, you get x. So example, log 100 to base 10 is equal to 2. Means that if you raise 10 to power 2, you get 100. Log 8 to base 2 equals 3 means that if you raise 2 to power 3, you get 8. So that's the simple meaning of logarithm. And then we go on to the laws of logarithm. The first law is what is known as the product law. So uh, product law simply transforms multiplication in logarithm in under logarithm to inside logarithm to addition outside logarithm. So the law is that if you have the log to base b of m times n, it is the same thing as log m to base b plus log n base b, like that. So, and if you have like mnp, so that would now be plus log p to base b. So as far as you have the product to a base, you can split it out like that. So the transforming idea is that multiplication inside the logarithm becomes addition outside the logarithm. So, so we can see logarithm as some kind of transformation, right? So that's the product law right there. So let's look at some examples that talk about this. So you have log 9x to base 3. That means you have log 9 to base 3 plus log x to base 3. And since log 9 to base 3 is equal to 2, so that means you have 2 plus log x to base 3. Well, we have not dealt with this law, but we are going to talk about it soon. So, so very, very soon we're solving more comprehensive problems. So, so you can expand, you can condense. So if you have log x to log x plus log y, that's the same thing as log xy. Of course, if you don't say the base, that means you're talking about base 10. So you can of course say this is log xy, log x times y. So then we go for the quotient law. The quotient law transforms division inside logarithm into subtraction outside it. For instance, the law says that the logarithm of m divided by n to base b is the same thing as logarithm of m to base b minus logarithm of n to base b. The transformation idea is that division inside logarithm becomes subtraction outside logarithm. And we have this kind of examples. Imagine log x to base 5 of x over 25. So you have log x to log x base 5 minus log 25 base 5. And because this is log 25 base 5 is equal to 2 from what we know, because if you raise 5 to power 2, you get 25. So that means you now have log x to base 5 minus this one, which is 2 now. Then you have another one. Log a minus log b can simply be written as log a over b, like that. So that's condensation. Condensing it is like the reversal. Now, this is the law I've been waiting for the longest, because we've come across several scenarios where we can use this. So if you have the log of m raised to a particular power k to the base b, then k comes back to multiply the expression. So this k, which is the power, comes to multiply log m to base b. So this power law converts exponent inside the logarithm to a multiplier. So a multiplier of the logarithm. So transformation idea is that an exponent inside becomes a multiplier in front. Okay. So look at this example one. So if you have log x raised to power 4 to base 2, that means you simply have 4 log x to base 2, like that. Okay. So all that, then imagine example two, you want to expand multiple powers. So you have log x cubed times y squared. Two things are happening here. You have the product law. So it means you can first of all say this is log x cubed to base 10 plus log y squared to base 10. Beyond that, you can then drop the powers. You can then apply the power law. This now means 3 log x plus 2 log y, and that goes. Then example 3, you have 5 log x, so you can condense it back. So you have log x, so 5 log x, it can simply mean that 5 goes back to on top of x, so you have log 5x raised to power 5, like that. So what if you want to expand mixed expressions systematically? So when expanding, the first thing you want to do is rewrite radicals as fractional exponents, then apply quotient rule, apply product rule, and then apply power rule. Okay, that sounds like a lot of English, but let's see that play out here. So you want to expand the log of x squared root y over z squared. So the first thing is you rewrite the radicals, right? So x cube is fine, but root y is y raised to power half. So you want to rewrite, instead of having this root sign, it's better you write it as a number, a fraction or whatever. And then this is z squared, okay? Then from there now, you apply the quotient law. So uh, to apply the quotient law, you have log x cubed y half minus log z squared. That is settled. The next thing is you can apply the product law because these two are multiplied. So you can have log x cubed plus log y raised by half minus log z squared that was there before. And then finally, you can apply the power law. So you have 3. So 3 log x plus half log y minus, this is log z squared, that's minus 2 log z. So the final answer is simply 3 log x plus half log y minus 2 log z, like that. So of course, you can also do the same thing with condensing mixed expressions systematically. So when condensing mixed expressions, move coefficients as exponents, combine addition using product rule, combine subtraction using quotient rule. That's all. And we have an example like this. So you want to condense 2 log a plus 3 log b minus log c. So first step, you can use the power law. So bring back the power. So 2 log a is log a squared, 3 log b is log b cubed minus log c, which has been like that. Therefore, product now. So you can use because you have log a squared plus log b cubed can be same thing as log a squared times b cubed together minus log c. So finally, because it's still the same log, so and this is minus this, so you can then turn this negate subtraction to division. So you have log a squared b cubed all over c. Okay, and then the final answer is log a squared b cubed over c, like that. So we can also do change of base, right? Now, in the last video, we discovered that there are two popular types of logarithm. We have the common logarithm, that's log to base 10, and there's exponential logarithm, and there's natural logarithm or Napierian logarithm, that's log to base e. So sometimes calculators only have log, that's base 10, and ln, base 2. So how do you now evaluate logs with other bases? For instance, you want to evaluate log x to base b. So generally speaking, to do log x to base b, it's the same thing as log x over log b in base 10 now. Well, or you can say log x to base b is the same thing as ln x all over ln b. Anyhow you want to do that. Well, that may be not so clear, but I think I should clarify. So imagine you have log b to base a, all right? This is just any two random numbers. Maybe not e, not 10, not anything like that. So, um, so to change to well-known basis, if you like, to change to well-known basis, anyone, whether maybe base 10, the well-known bases are base 10 or base E, okay? So if you want to change to that, what do you do? To change this expression now, this guy, to well-known basis. So what do you do? First thing, you say let log b to base a be equal to x. Okay, so if that is the case, it means that b is equal to a raised power x. We know that much. So next thing, you can now take maybe log to base 10 or log to base e of the two parts now. So anyone you choose. So if you choose log 10, you just say maybe next thing, log take log or ln of both sides. Take log or ln of both sides. Anyone you choose. Of course, you can only choose one per time. So anyone you choose is fine. So let's take log to base 10. So I just say log b. Now it's now base 10 equals log a raised power x. So we then have log b from power law, this actually becomes x, the power here becomes multiplier. So we have x log a. And since we are looking for x, right? So we can then divide through by log b. I mean by log a. So we have log b all over log a equals x log a all over log a. So this cancels out. So that tells us that x is equal to log b all over log a. All right. So we can say that log b to base a is equal to log b all over log a. That's log 10 to base b all over log 10 to base log b to base 10 and log a to base 10. Or if you like, just write log b over, once we don't write the log, that's base 10. Log b over log a. Or you can also say that um log b to base a is equal to ln b all over ln a, okay, which is the same thing as log b to base e all over log a to base e. Anyhow you choose it, you are good to go. So whatever, no matter if you don't see familiar logs, you can just use this conversion method. So look at this now. Look at this example. Evaluate log 7 to base 2. So once you see this, don't be afraid. Just say it's the same thing as log 7 over log 2 in either base 10 or base 2 base e, right? Like that. And then you can just evaluate that using your calculator. Log 7 over log 2. So we have log 7. Okay, I think it's better to do this. Log 7 divided by log 2. So we have this. Now let me try ln 7. Ln 7 all over ln 2. Yeah, we get exactly the same thing. Okay, so anyhow you choose it, 2.807 there. Then here you have log 3 to base 20. That's simply ln 20 over ln 3. Okay, and you get approximately 2.73 in that regard. So in summary, we see that inside the log, and we see that this law tells us how, well, if something is happening inside the log, what does it translate to outside of the log? So multiplication inside the log means addition outside the log when you split things up. Division inside the log amounts to subtraction outside it. Power inside the log amounts to multiplication. That's coefficient multiplication outside the log. So some common mistakes that may happen, which you should pay attention to. So it is not true that log x plus y is equal to log x uh, plus log y. This is not true. So it is when you have log x times y to a common base that you then have log x plus log y. But log x plus y like this is not equal to this. They are totally different. So in fact, I think I want to buttress that a little bit. If you have log x plus y, okay, it's maybe you have log x plus y equals 3, for instance. So this is base 10, of course. That simply means 10 raised power 3 is equal to x plus y. Okay, so it means you just still need more information to get x plus y if you need it in whatever way. Okay, so and it is not equal to, so we're saying that log x plus y is not the same thing as log x plus log y. But the only thing that is log x plus log y is when you have log x y, x times y, then that is actually log x plus log y. So there are two different things. So pay attention to that so you don't make that common mistake. All right. So always log argument must be positive. So always log argument must always be positive, right? Move coefficient as exponent when condensing. So you have to move the coefficient to become power. Then expand in the correct order, quotient, product, and power. Okay, so I'll take a couple of questions, maybe one or two from the practice section so that we can drive on the point. So let me take anyone that might look really problematic. So I think I want to take question 8. Question 8, log x cubed root y z4. So and what we are told to do there is to expand the following expressions. So we have, or maybe I should take log 10. We've done something like this before, so not a problem. So we have log x squared y raised power 3 over z. Okay, log log x squared y raised to power 3 all over x squared y raised to power 3 over z. Okay, over z. In fact, I can even complicate it and say over 4th roots of z. So that I'm going away from that problem we have there. So what do we do here? So first of all, we write make sure everything has its own power. So here it means we have x squared raised to power 3, then y raised to power 3, all over z raised to power 1 over 4, right? So first step. So second, we have log, that means we have log x raised to power 6. That's power of power, multiply the powers. Then y raised to power 3 all over z raised to power 1 over 4. Okay, so the next thing we can do quotient, and that means we have log x6 y3 minus log z 1 over 4, because this one is, we have a division there. Then next we can do product. So we have log x6 plus log y3 minus log z raised to power 1 over 4. And then we can finally do power law. Okay, we can do power law that all the powers come down. So we have 6 log x plus 3 log y minus 1 over 4 log z. Okay, that's what we have for that. So mind you, I adjusted this from the original problem. Okay, so I'll take another question from the last 20. So condense the following expressions. We have log x plus log y. Of course, that will just be log xy. 3 log x is just log x cubed. Log a minus log b is log a over b. 2 log x plus log y. Of course, that will simply be 2 log a, 2 log x plus log y. That will be log x squared plus log y, which will be log x squared y. Then 4 log x minus 2 log y, that'll be log x raised to power 4 minus log y squared. So that'll be log x raised to power 4 over y squared, like that. Log a plus log b plus log c, that's simply log abc. Then 5 log, okay, I mean, we can do all this. So let me just take log number 19. Log m, 3 log n minus 2 log p. Log m, log m plus 3 log n minus 2 log p. Okay, log m, 3 log plus 3 log m minus 2 log p. So we have this. Yeah, first thing we want to do, take away the, reverse the power. So we have log m plus log n raised to power 3 minus log p squared. Okay, that's what this is equal to. Next thing we can do the what is it called now? We can do quotient, right? So that we have, or we can even go straight. We can go straight to, we can just say log into m n, because this is addition. So we have mn power 3 all over p squared, and that's the final result. Okay, that's how that goes. Yeah, so with this, I come to the end of this interesting video about the laws of logarithm. So check out the 10 questions, try your hands on them. The first 10, try your hands on them and see if you really get the gist. Then try out the other 10 also. Make sure you understand. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. If you haven't subscribed, go ahead and subscribe right now, and hit the notification bell so you can always get alerted each time a new video is released. Well, I mean, this question 20 is calling my attention, but it's okay. Well, this is just going to be log a squared c over b raised to over cube root of b, you know. So beyond be subscribing, you can also become a member of the channel by clicking on join, which gives you some special privileges, like getting to see some videos first, or some videos made for only you, or we can hang out together to talk about whatever interests you on my channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing math right. Bye.